So I wanted to do another example of one-sided limits using this piecewise defined function behind me. So the first piece is defined as 3x minus 1 if x is less than or equal to 2. The other part says that x squared plus 1 when x is greater than 2. So the limits that I'm going to find this time are the limit as x approaches 2 from the left side. Notice again, that little minus sign reminds me to plug in numbers that are smaller than 2 to approach it from the left. The other one I'm going to find is limit as x approaches 2 from the right side. Remember that plus sign means, again, plug in numbers bigger than 2. Try to do it from the right side. And the last one I'm going to do is the limit as x approaches 2. That's one of those two-sided limits, so I wanted to make sure I did one of those. Now, I'm going to do this a little bit differently. So I'm going to actually do it both numerically and graphically. I just want to make sure I show you guys the relationship between both of those. So here I go. I'm going to start off by doing the first piece, the 3x minus 1 when x is less than or equal to 2. Now, hopefully you guys remember 3x minus 1 is a linear function. That negative 1 at the end is actually the y-intercept. So I'm going to start here at negative 1, and my slope is 3. So that means I'm going to go up 3, 1, 2, 3, and over 1. I'm going to go up 1, 2, 3, and over 1. Now I'm going to stop right here, and here's the reason why. It says we're only using x values less than or equal to 2. So I can't plug in things like 3 and 4. It's going to stop right here at 2. So it's actually going to look more like a ray than a line. Now I'm also going to make sure I mention while I'm standing up here talking about it that this is a closed dot. The reason it's a closed dot is because it's less than or equal to. If it were just strictly less than, we would put an open dot there. But it says less than or equal to. The key is the equal to. I'm putting emphasis on it. So, again, it's starting here at the 2 and traveling left. So, hopefully you guys are picking up on this. When I approach it from the left side, from the things that are less than 2, it's increasing toward 5. Now, let's just check that numerically real quickly. So again, I'm approaching it from the left. I'm approaching it from the negative side. I'm going to plug in numbers that are less than 2. So let's pick some numbers that are kind of nice and easy. Let's do, I don't know, 1.9. Let's do 1.95. And I don't know, let's try 1.99. So notice again, we're approaching 2 from numbers that are less than it. So I'm going to plug in 1.9 and see what happens. So 3 times 1.9 minus 1 gives me 4.7. I'm also going to try 1.95. So when I plug in 1.95, it gives me 4.85. And when I plug in 1.99, it should give me something really, really close to 5. It sure does, 4.97. So as we're going, we seem to be getting closer and closer to 5, which is good. That's what my picture showed me as well. We're getting closer to a y value of 5 up here. Now, that's great. That's the left side. Okay? Now I'm going to try to focus on the right side. Now, the right side says that we're going to do x squared plus 1 when x is greater than 2. So I'll go ahead and start off doing that one numerically, and then I'll come back to the graph. So again, we want to do this from the right side. So now I'm going to start plugging in some numbers that are bigger than 2. So I'm going to come over here to my table. I don't know, I'm going to kind of match it up with what's over there. So I'm going to do 2.1. I'll do 2.05, and I'll do 2.01, and we're going to see what happens. So if I plug in 2.1 up there, 2.1 squared plus 1 makes 5.41, okay? If I plug in 2.05 squared plus 1, I get 5.2025. All right, and let me plug in the last one, 2.01, and see what happens. I got 5.0401. Now notice, these are decreasing. So 5.41 to 5.2025 to 5.0401. It seems like it's also approaching 5. So let me go ahead and try to graph that real fast. So I'm going to, again, just see what this looks like. Now, x squared plus 1 is a parabola. It's got that x squared, so it's going to have a U-shaped curve. So if I started off with, I'm just going to say the number 3. 3 squared plus 1 is 10. So it's actually way up here at the top at 3, okay? And what it's doing is it's curving down toward my function. And we already plugged in these numbers, and we said that it's getting closer and closer to 5. So it's curved, it's not straight, but it is approaching 5. Now, at the end of this, I would like to put an open dot, but there's already a closed dot there. So I'm just going to leave it as that closed dot. So we've got a U-shaped curve here in red, and this very, very straight line or ray in purple. But either way, this is approaching 5 from the right-hand side. They're decreasing, headed toward the number 5 as the y value. Now, here's the thing. Since both of these two, the left side and the right side, since both of these two sides went to the same number, they both went to 5, that means that my two-sided limit, the limit as x approaches 2, is also 5.